In today's lesson here, we're going to be taking a look at the ambiguous case for the sine law here. So let's take a look at the following setup here. So for this first example here, they give you the following information. I know I have a triangle, and I know that one of the angles is 20. So I'm going to go ahead and sort of draw this triangle. I know one of the angles on this triangle is 20 degrees. That'll be angle A. Directly opposite is going to be my length, and then my leftover length here is going to be the 25. So I've went ahead and drawn that here, and I have this triangle here, and I make the observation is this is the only way that I can draw it. Like I've drawn this as an acute triangle. Is it possible that a second option for this triangle exists? Well, what you want to do here to examine that and see whether, and this is where the ambiguous part comes into play, is you want to find the height of this triangle. So I'm going to go ahead and find the height of this triangle here. And if I find the height of the triangle, I know that my h value is going to be 25 sine 20 degrees. And if I calculate that, we end up getting 8.55 as the height of this triangle. So you see, since this is 8.55, I know that the acute triangle I've drawn, this exists, it makes sense. You can create this triangle. However, I could have also kept the 25 just as it is, had the 20 just as it is and unchanged, and then I could have actually rotated this leg over here, and it would still be a 10, this would still be a 20, and this length would still be a 25. So you notice that I've kind of redrawn my triangle as follows, and this still satisfies this condition. I have my 20-degree measure, I have my 10 for my length, and I have my 25 for my length of that side. So in this situation here that we're given in this example, this is an ambiguous case in that for this given measurements and lengths, right, given the following side-side angle, I can either have an acute triangle that they intend me to draw, or perhaps I have myself an obtuse triangle that I need to be drawing. So both of these are possible. So in this case here, it creates two different options for a triangle. Let's take a look at some other options and differences with the ambiguous case. So for the next example, again, same idea. They've given us some conditions here. I've got an angle 70 degrees, length of 7 and length of 5. So again, I'm going to draw this assuming I have myself an acute triangle. So this angle here is going to be 70 degrees. This will be 5 and this will be 7. Again, I have side angle. And then I'm going to make the observation here. I'm going to go ahead and check out this length here. If I go to calculate the length this time, my h is going to be 7 sine 70. And my h value here comes out to be, I'm getting 6.58 as the length here. So right away we have a problem. And the problem we have is the length of the height of my triangle is greater than this hypotenuse here. If I view this as a right angle triangle, which it is, right? I can drop the altitude line down. I have myself a 90-degree angle. I've got that one of the legs of the triangle is actually larger than the hypotenuse. So that means the way I've drawn this triangle is actually incorrect. It probably looks something more like this, where this is 7, this is 70, and this is 5. This leg of the triangle is not long enough to connect. So again, I tried to draw this triangle, and it's not even possible to create, so this would be no triangle exists in this case. So again, sometimes I can be given some measurements, some angles and some lengths of a triangle that are not even possible to create. All right, let's take a look at another example. So in this example here, we want to take a look at these dimensions here. So I've got here angle again. Let's make that 63 degrees. So I've got 63 degrees here for angle C. This will be a 12, and this will be a 9. Now, if I got this question here, I go ahead and, okay, I want to check the height and see what's going on here. My height this time is going to be 9 sine 63. And if I go ahead and calculate 9 sine 63, I end up getting approximately 8.02. So it is possible that I could go ahead and leave the 9 just as it is, the 63 just as it is, And then I could maybe have something like this set up, but right away we have a problem here. And the problem that's going to arise with this, so like I know that this triangle here does exist. If I did try to construct myself an obtuse triangle, leaving this as a 12, this as 63 degrees, and this as 9, we would have a problem because my obtuse angle must have the largest side, right? The largest angle gives the largest opposite side. So in this case here, I'm expecting this to be the largest, and I don't. I have this as a 12. So right away, this option that I have here does not exist. And in this situation here, this is only one triangle exists for this situation. So I thought I'd highlight that. These are the three conditions that you have for the ambiguous case for sine. You can have yourself a situation where you have two different triangles, one acute and one obtuse. You can have a situation where you have no triangles existing. And lastly, you have a situation of one triangle exists. And this would be one situation that would arise. Thank you.